In this video, I will explain why regression and classification are different problems. So in the previous week, we have discussed regression task, but from this week, we will talk about the classification. In classification task, usually the output is qualitative variables which take values in an unordered set, let's say C. Right. So actually, it is hard to say regression and classification are totally different, so we cannot use regression algorithm for classification, or we cannot use classification algorithms to regression tasks. There are actually some tricks we can reuse same algorithm we already used for regression to classification and vice versa. So, for instance, for the example of regression problem using classification algorithm, consider the case the output y in the range between 0 and 10. We can basically split the input values into several different disjoint range, like 0 to 1, 1 to 2, 3, 9 to 10, and we can assign some class label to each range, like this is label 1, this is label 2, up to this is label 10. This is okay. Then the output y essentially belong to one of set, and so we can assign one of class label to each output y. So now we basically transform the regression problem to a classification problem. So we can use all the classification algorithm to fitting the regression task before, which is possible. But the problem is this technique introduces additional bias error. Okay, so that makes the accuracy worse than before. So usually we do not use this trick. We do not convert the regression task to classification task, except very few special cases where very nice classification algorithm we can utilize. But forget about the special cases. And in this class, we will use regression algorithm for regression task. We will use classification algorithm for classification task. Okay, let's consider one more example. We can change the classification task to regression task, like this. For instance, if you want to make classification algorithm for, let's say, handwritten digits. So you have a bunch of handwritten numbers, and then you want to build a function such that when you put some handwritten digit to here, then the output is output just indicate the what's real value for the handwritten digit. Essentially, this is a classification task. We have to classify input handwritten digit to one of class label, like real number 0 to 9, let's say. But we can convert the classification task to regression task by using the number, the actual number. Like this is class 7, but this is also number 7. Okay, so this is real tricky, but yeah, that is true. Then maybe you can make some regression function f, such that if you put some handwritten value here, like here, this f hat value give you some number close to 7, and you can define some mean squared error like 7 minus 6.8 square to define the rows of your regression function, and you can train your model, regression function model, by optimizing the mean squared error. That is absolutely possible, right? You can certainly use the regression function to classify handwritten digit from 0 to 9. But one very critical problem for this regression approach is this. Basically, many handwritten digit 1 and 9 sometimes looks very similar. So there could be many misclassification. But sometimes you also very confused from 3 and 1 as well, if the value 3 is very weirdly written, or 3 and 9 also very not clear to discriminate. Okay. But it is hard to say which misclassification is worse than the other misclassification. But when you assign some real number to each class, what will happen is basically the misclassification between 1 and 9 can introduce a very huge mean squared error. Right? So if your regression function f makes some value a because the regression function thinks the input handwritten digit looks like a number 9. This is just a misclassification, but the regression error is 1 minus 8.8 square. But if you confuse between 1 and 3, so your regression function makes some confusion and makes some wrong decision like a 1.3, then the mean squared error, the residual square value for this misclassification is just a 3 minus 1.3 square. Huge difference. Okay, so basically when you train your model, your training process will be dominated by this huge error. Your function will try to fit your value between 1 and 9 rather than the discrimination between 1 and 3, because the error between 1 and 3 just incur very small value compared to the error between 1 and 9, which can make a very bad result in the end, right? So that's why people do not use regression function for classification task.